Have you ever really thought about what's under your feet? I mean, really thought about it. It's so much more than just rock and dust. In this explainer, we're going to pull back the curtain on the incredible process that turns solid, lifeless bedrock into the living foundation for pretty much all life on Earth. So let's dig in. First things first, we've got to ask a really basic question that actually gets to the heart of everything. What is the difference between dirt and soil? Now, you might think they're the same thing, just different words. But as you're about to see, they are worlds apart. And this slide right here lays it all out. On one side, you've got dirt. Think of it as just lifeless mineral dust, a bunch of disorganized particles. But on the other side, you've got soil. And soil is a living ecosystem. It's a structured matrix that is absolutely teeming with billions and billions of microbes. Life, it turns out, is the secret ingredient. And look, this isn't just a minor detail. This quote from our source material makes it totally clear. Without all of these living organisms, soil just doesn't happen. You get dust that blows away in the wind. These creatures aren't just living in the soil. They are the very reason soil even exists in the first place. Okay, so how does this incredible transformation from rock to a living matrix even begin? Well, it all starts deep, deep underground with solid bedrock. This is stage one. Breaking down that parent rock into the mineral building blocks that are going to become soil. So how do you break down a rock? Turns out there are three main ways. You've got your physical forces, right? Like water getting into cracks, freezing, and splitting the rock open. Then you've got chemical weathering, where water and other stuff start to dissolve the minerals. But the most powerful and honestly the coolest is biological weathering. This is where life itself actively gets in there and just dismantles the rock. And I want you to meet the absolute pioneers of this process, chemolithotrophs. The name literally means rock eaters, and that is exactly what they do. These are bacteria living way down in the earth, and they get their energy by essentially eating the iron in bedrock. They are literally chewing up the rock from the inside out, starting the whole soil creation process from the bottom up. How wild is that? All right, so once the rock starts to get broken apart, a whole new crew shows up. And these guys, these are the architects. They're the microbial master builders who take all those little mineral fragments and start to construct something completely new. And they come prepared. These microbes have this amazing chemical toolkit to mine the rock. Fungi, for example, pump out organic acids. Bacteria can produce alkaline compounds. They create these things called biofilms to stick to surfaces. And they even use these specialized molecules called cytophores to literally reach in and snatch iron atoms right out of the rock. Let's take a closer look at that biofilm, because it's not just some random slime. It's a highly organized shared home that the bacteria build for themselves. This sticky matrix protects them, lets them all communicate with each other, and it basically acts like a concentrated little factory, focusing all their rock-dissolving chemicals right where they need to be. It's incredibly efficient. Okay, so we've broken down the rock. We've mined the minerals. Now comes the really fun part, the construction phase. This is where all those lifeless mineral particles get woven together with organic matter to create that living matrix we call soil. So the basic mineral framework of any soil is what we call its texture. And that's really just the mix of sand, silt, and clay particles. You can think of these as the different kinds of bricks for our building. That specific ratio of these three things determines a lot about the soil's basic properties. But here's the key. A pile of bricks is just a pile of bricks, right? It's not a house. The crucial point, the real magic here, isn't in the particles themselves. It's in the biological glue that microbes create to bind everything together into a stable structure. And here it is. This is that magic glue. It's called extracellular polymeric substances, or EPS for short. Basically, these are super sticky compounds that bacteria produce, and they act like the mortar for our soil. They coat all those mineral bricks and start sticking them to each other. So here's how that whole building process actually works. First, bacteria use that sticky EPS glue to form these tiny little clumps called microaggregates. But then it gets even cooler. These long, thread-like fungi, called hyphae, act like rebar. They weave through all those tiny clumps and bind them together into bigger, much more stable structures called macroaggregates. And that is what creates all the little pores and channels that hold air and water. So what about the organic side of things? Well, this chart breaks it down. It's a mix. You've got decaying plants and these really stable compounds called humic substances. They make up most of it, but check out that last 10%. living organisms and their dead bodies, which scientists call necromass. Now, 10% might not sound like a lot, but in grasslands, this microbial necromass can actually make up over 60% of the soil's organic carbon. So why is this organic matter so ridiculously important? Well, this chart shows you why. It's all about how well different parts of the soil can hold on to nutrients. You can see sand has almost no grip at all. Clay is definitely better, but look at organic matter, it's off the charts. It's basically a nutrient magnet, and that is the absolute key to having fertile soil.
So we've taken this wild journey all the way from inert rock to this incredibly complex living system that's literally built by microbes. But so what? Why is this so critical? Let's connect all this amazing science to why it matters for every single one of us and for the entire planet.
You see, a healthy, living soil isn't just sitting there. It's constantly working. It holds onto water and prevents erosion. It cycles the nutrients for all plant life. It acts as a massive carbon sink to help regulate our climate. It's one of the most biodiverse habitats on Earth. And of course, it is the foundation of our entire agricultural system.
And if you need just one number to really let this sink in, remember this one: 58%. Soil organic matter is 58% carbon by mass. That simple fact makes the world's soils one of the largest and most important reservoirs of carbon on the entire planet. It plays a gigantic role in regulating our climate.
And that brings us right back to the beginning, but with a completely new perspective. We've seen that soil isn't dirt. It's a dynamic, breathing, living system. And that leaves us with one final and I think really crucial question. If soil is in fact alive, how should that change the way we treat it?